This research paper proposes a novel approach to image caption generation, leveraging large language models to produce contextually appropriate captions without processing images. The authors distinguish between image descriptions and captions, highlighting the limitations of current deep learning models in generating practically useful texts. They utilize the Concadia dataset, which consists of images with descriptions, captions, and surrounding context, and propose a method that does not require image processing. The authors describe their prompts and fine-tuning approaches, including the use of the CIDEr metric for evaluation, and discuss limitations such as potential bias in generated captions and implications for deploying models at scale. The paper highlights the potential of this approach to bridge the gap between deep learning models and practical image captioning tasks. Recent research in image-based natural language generation has identified a significant gap in the practical usefulness of current models. The introduction of clip models in 2021 demonstrated remarkable transfer capabilities, sparking a debate on the role of language in visual representation learning. A 2022 study systematically compared matched versions of SIM-CLR and clip models, finding that the utility of language supervision is dependent on pre-training dataset properties. The study proposed algorithmic improvements and dataset modifications to better utilize language supervision, highlighting potential risks of incorporating biased language into visual representation learning. The paper also references the introduction of VinVL, an improved object detection model providing object-centric representations of images, which achieved better results than state-of-the-art models on a range of vision language tasks. The authors emphasize the importance of visual features in vision language models, providing a comprehensive empirical study and ablation study of their pre-trained object detection model. The research paper emphasizes the significance of visual features in vision language tasks, particularly focusing on object detection models. A comprehensive empirical study is presented, demonstrating the utility of visual features in VL models and introducing a novel object detection model that significantly improves state-of-the-art results on major VL tasks. The authors also provide a detailed ablation study of their pre-trained object detection model. For evaluation, the Concadia dataset is used, comprising 96,918 images from Wikipedia along with their associated context, descriptions, and captions. The CIDEr metric is employed for evaluation, as it captures the semantic similarity between generated captions and reference captions more accurately than blue and rouge metrics. Furthermore, the authors leverage large language models for image captioning, focusing on the CIDEr metric. They utilize higher-order NGRAMS to capture grammatical properties and richer semantics, combining scores from NGRAMS of varying lengths. Initially, zero-shot learning was attempted but proved challenging without fine-tuning. After fine-tuning the Cohere-based model on 100 random data points, they achieved a CIDEr score of 1.73, surpassing the state-of-the-art OSCAR-VinVL model's score of 1.14. However, limitations include the inability to fact-check generated captions for truthfulness, as evident in Figure 3, which incorrectly identifies mission crew members. Future research should incorporate modern fact-checking methods into the model's text generation pipeline. The authors concluded by discussing the potential for leveraging machine-generated image descriptions instead of human-written alt text to improve the quality of captions. This research paper explores attributed text generation via post-hoc research and revision, focusing on enhancing the accessibility of visual content, particularly for images taken by individuals who are blind. The authors leverage advanced techniques in machine learning and artificial intelligence, drawing upon studies and tools like Caption Crawler, Concadia, and CIDEr. They emphasize the role of language models in generating high-quality captions, referencing the Microsoft COCO dataset for evaluation. The proposed approach utilizes large language models, such as GPT-J6b, with reinforcement learning and human feedback to refine captions. Evaluation metrics like blue, rouge, and CIDEr are used to assess the generated caption's similarity and quality. The results demonstrate the effectiveness of the proposed method, significantly outperforming existing state-of-the-art models. This research contributes to advancing accessible visual content by integrating natural language processing techniques with visual understanding models.